As usual, the sun is starting to go down and I'm now about to start something new. Anyway, this is a kit I got to repair from a friend of mine. Some nice locking hinges, and it's essentially a survey equipment device. And let me see, I've got the manual here. What does it say? It's a Berger LM30, and essentially this is the remote control for it, where you can control it, put it on and off. Oh, actually that works, look at that. Right, that doesn't work, that doesn't work. At least that works. Blue, red LED. I see. Right. Um, no, I guess this is for the civilian equipment. A really cheap supposed laser lens. And yes, it's been open for a while, so there's quite a lot of little spiders in here. That didn't make it actually. Right. Attachment to the base, attachment device, and essentially the actual device. It wasn't working, wasn't coming on. It uses 4 C-size batteries. I've opened it up. I have not been able to fix it. What I'm trying to do is really more document what it is, how they did it, what they used, the picks and everything else. As you can see, attachment here, screw meant to go in here, so this could all screw up. This actually fits this way. This top piece here spins, and that's where the laser is. We'll get to that and you'll see that. So yeah, there's 3 different things here. Is for leveling, so we're able to level, and then there's a spring on this side. Right, so let's get into the insides of this, see what they built. The design per se isn't bad. There's some things I don't like about it though, so we'll get to it. So the first thing is removing this cap here, 2 screws, cap comes off, and that's basically the whole device. You just lift this and the whole thing comes off. That's because those screws are out, because I didn't put those back in apparently, so yeah, can't remember that. Alright, having a look at the device now. This board, this front board, is essentially what's behind this. So if you look at them next to each other, what we can see, LEDs 3 by 3, indicators 3 by 3, on off button, little what you call it, window, infrared sensor for the remote we just pressed. And essentially that's what this is. This is just our control board, our tactile sensors, indication board. This has no control per se in it, no microcontroller in it, right? I say control board. This is where we are interfacing with the device, but we have no microcontroller on this board. It is a daughter board. The main board is behind that, so we'll get to that. Alright, again, windows. This gives us indication, leveling this way and that way, right, as is typical for these devices. So let me get a little bit more removed and we will look back again. As I'm opening it up here, I'm taking all the 2 screws, and this is the one. I realize maybe I need to show this. One of the things I don't like with this, before I pull it apart, that part of it apart. Let's take a look at this side. What they've done essentially is they've put a motor here to rotate the top there. If you notice, the top is rotating. This is essentially a prism. It comes up, the light hits and reflects out, so we get a horizontal beam. From a vertical beam, there's a laser on the bottom here. It hits and reflects straight forward based upon the prism in the back there. Right, this is the motor. It's particularly small. That's my first issue. And the second issue is, if you look at this, when it's turning, there's a kind of a lip in it somewhere there that causes it to act imbalance. It doesn't run smoothly. I don't like this belt. Now that wasn't the only problem. The other thing with it is, have a look at this belt. See how easy that is moving? That is not acceptable, right? This belt is way look at this. I can stretch this belt like this. That is unacceptable. You cannot get proper transfer without some decent friction, and this does not have the friction to give you any proper transfer of the power to this. So this does not spin properly. There's also a point where the joint and it shows when it's spinning, you get that kind of thing. So let me show that first now, and let me go back to stripping, because when I pull this out, I'm not 100% sure this will be easily visible. Might be easier to show again. Gotten a little further, let me show these spacers are between the plastic molding and to make up the space to hold up this device here, and there are 3 of them obviously because there's 3 screws. That's the kind of thing I would do. That's the kind of thing I would do when I'm doing a project and I didn't think it out correctly. And you know, it's the easiest thing to do, just put a spacer in between there and that works. When you're designing a project like this, and this size, this level of device, this is done in 3 dimensions, these mistakes don't occur. This is a mistake. This is a cock up that somebody tried to fix by putting in these. Now it's an acceptable solution, huh? Don't get me wrong. It's not a professional solution though. That's what I'm not happy with. Right, so ribbon cable joining this board to this board. Straight connector coming in from the battery terminals. So the power comes onto this board and it's going to this board via ribbon cable, which I don't particularly like. I would have said, let's get us some proper copper connector here and do this and do the ribbon cable just for sensing and putting these LEDs on, letting them, you know, show. Onto this board now. Is it visible? I'm not sure it's visible, but this is a PIC 16F72. So PIC microcontroller and a dip version at that, which I guess the reason they're doing this, there's only one reason to do a dip version of anything in this day and age. That's more work. That requires soldering after, but then you have the soldering and a couple of these other things that will have to be manually soldered. So not necessarily the biggest deal, because really and truly SMD components like these are the easiest thing. Pick and place machine, put it down, cheaper. So only one reason to do this, and that reason, they didn't put a tag, a header for programming this. So this chip is pulled out, well, not put in, it's programmed externally and then plugged in, and essentially that's the approach they've used. Instead of putting a header here and having a surface mount chip 16F and then just programming it on board, one way or the other, I mean, you know, you could argue this way or that way, is what they chose to do. I wouldn't do this kind of tip package, and that's why it's able to pull out, and that's why it's not soldered in. It's in a header to be able to plug in one of the sockets. I wouldn't do it that way, but that's just me. Now, this is the laser we're talking about. 635 nanometer laser, essentially red. Connector for the laser, the 3 connections that you normally get for a laser, and it basically runs straight through the device. As I mentioned, this laser shoots through the center of this shaft, so the shaft is hollow. There's a circle here, hits it up there, hits that pyramid, that prism, and shoots out vertically. This is spinning via the motor, and basically it will give a level line. So once I rest this device down, and I level it properly on my stand, because the stand wouldn't be leveled on the ground, and you level that correctly as per these 1, 2, 3. So I'm leveling in this plane, I'm leveling in this plane, and I'm checking vertically if I have an issue, or if I turn this device in a direction. What happens also is, essentially, when you're vertical, the bubble will be all the way up, and then you'll have these 3 working with. But what happens when you turn the device side? Let's say you want to get the side of a thing and make sure it's parallel. That comes into play then. So maybe this and that and this one, or it could be that and this one. So essentially, all 3 axes, bubbles, the spirit levels, I don't like them. Yes, they work. Yes, they're okay. Highly inaccurate. I mean, for this level of device, I don't like them. I mean, but yeah, they work. So as you see, they've been put in here. Chances are they're epoxied. Some I'm feeling silicone here. Okay, silicone in, and then held in position by some locking screws with hex nuts. And as I said, this is the main controller board, this is the main board. We'll strip and get a little further, have a look at this. And the problem with this device, just getting back to the whole overall why I was unable to fix it. Number one, that belt was problematic, and getting a belt is neither here nor there. When powered on, the device sometimes comes on, sometimes it beeps a little, and it doesn't function. The motor doesn't spin, and laser doesn't come on. Now, that is a controller problem. That's not both devices not working. When I put power to that motor, it spins. So that's what I'm saying. I see the irregular movement. It spins. It works. Problem is the controller is not turning on this motor. The controller is not turning on this laser. So it's a controller problem. Now, most of these controllers, you're able to lock them, and you can't even get to be able to download the code. Far less that's in a hex file. Alright, so you do the programming, you send it across via hex file. Even on Arduino, while you see a nice little interface on your screen, it's a hex file that's sent over. So you really to reverse engineer this and try to decipher that and fix the problem. That's getting into some serious, effort, if at all possible. Second approach here would have been grab this board out, take this out, take that out, run them manually. Could be done. Don't know the spec on this. Chances are will burn that laser very quickly. Right? Or I'll have to underpower it and hope it works. It's like high enough probability you're going to burn that. Because I don't have a spec on it. There's no writing. I've taken this out before and we'll take it out again. There's no writing on it. There's nothing there to tell you this is part number X and this is the specs. This is what you could do with it. Alright, again, the Moto 2, I don't think it has much information on it. It's stuck into here, so if there's any information, it's probably printed there. That number alone doesn't make sense. It doesn't find anything if I recall correctly. So yeah, there isn't that much you could be done with it. I can get it to spin, I can get it thing, and it was a little stiff too. This is a little stiff for me. This is not really what I would expect. I would expect a bearing inside here, and I would expect it to be, if I do this, right? Look at this. This should be spinning freely. With this kind of resistance, that motor is way too small. That belt is way too loose. This won't work. So by the time you finish trying to fix the shaft, replace the controller, guess what exactly this, operates at, and this. Yeah, you basically built over the whole damn device. All you have basically used is the machining of this, and the alignment might be good. That's about as best as you're going to get, so it wasn't worth it. But I like the attention to detail inside. I don't particularly like a few little things, but it's a well made product. But as in anything, regardless of how well it's made, sometimes things fail. This one has failed. Let me strip a little further. Let's have a look a little bit further, but as this isn't that much more to see anyway. So I haven't taken out that one screw. I'm getting this to pop open. I need to try to do this with one hand. Right, it's stuck on there. Cutting it off doesn't really make sense. There isn't much more we could see on this side of the board. As you could see, to get this board out, while there are a few screws, one here, one there, and one in the corner here, it does require that this shaft is removed. Right, that requires taking out that circlip on the other side and the head. That head will have to pry out because I just turned out the little set screw it has there, that little screw there, and it isn't coming out. So that means that has to pry out. There's a locking pin, it looks like, here. So that has to come out. All of that just to see the other side of this board. Now there are a couple of chips inside there. It's possibly visible. Isn't that much we're going to learn. Chances are that is really just to power the motor, maybe some motor controller, because this pick would not have the capability of powering that motor directly. So most likely that's just for powering the motor. It may have the ability to power that laser. This is the laser itself, separate on outside. Looks like a decent quality laser, I must admit. Nice little device, but again, not a single piece of writing on this. It's not possible to just guess this. I would hate to just put it on and burn it. Yes, it's not useful not knowing what it is, but so this is just essentially where it is, little pieces, the little parts in there, and it isn't really that much. It really is an extremely simple device. It really is just a matter of the precision in the manufacturing, and it doesn't even have to be that precise because there's set screws and adjustments to work. And if we look straight down inside, we could see the glue from outside here, from the prison. We could see directly where that laser is going to hit and how it's going to come out. So let me set this back up together and call it a D on this. It's just a review of how it was built, what I didn't like, what I liked about it, and essentially it was just the belt. I wasn't really too pleased with that belt. A gear system might have been better, or proper belt system actually. Belts aren't bad, but just this one didn't really work out very well. The material is too flexy, it doesn't work. It seems like they weren't really too sure, and they got a too rubbery belt. I'm not impressed. And again, a header and surface mount chip. Not when this day and age, this is doesn't go down well with me. And power via a direct connection, not through a ribbon. I mean, yes, it's specular work. In fact, all that dangling I've done, look what I've done with that ribbon. I need to pull that out properly and then put it back in. Just to cap off the last comment on the accuracy, these two screws up is here, just in the laser, that's to align the laser so to make sure it actually hits the center. This is actually, as you can see, sand cast. Alright, it's a rough finish. So this is a sand cast part. Look at the line here, it's just ground. This isn't really extremely high precision. I'm not saying it's really low. Look at this. So it's not extremely high precision. What is done is it's made to a reasonable level. Don't get me wrong, this is some nice fine sand, decent casting, machined out in some kind of jig. But there's some adjustment screws and adjustments in the whole thing to make this thing work. So you don't have to be extremely super precise in building something like this. You just need to have the adjustments in it and calibrate it after.